So, good afternoon, everyone, and welcome to today's lecture. This is lecture number 9, and we are going to deal with the capacitor circuits. In the previous class, we had seen some examples of questions, and we had seen what type of question come. We had seen the energy equation of capacitor. What was the energy equation of capacitor? Anyone? What was the energy equation of the capacitor? Anyone?
L plus work done by battery plus external work done is equal to U final plus H, sir.
Okay, chalo. We remember this. That is a good sign. So we had seen that energy equation in a capacitor circuit, and we had solved some problems based on that circuit. We had found out the work done by the battery and the energy given out in the form of heat when connections are changed. Okay, up till now, apart from this case, um, and the previous one, the capacitor was initially uncharged. Only in these two cases, the capacitor was initially charged and then we connected it to a different battery. Now, what would happen? Up till now, we were dealing only with one capacitor and maybe one battery only. As I told you, if it is a case of one battery, we can solve the question by series parallel combination. Even that is not possible if one of the capacitor is initially uncharged. Because if one of the capacitor is initially uncharged, then the situation becomes somewhat different. So now let us move on and see some general concepts of capacitor circuits. And the first concept or the first thing that we are going to see are your favorite, Kirchhoff's law for capacitors. Now, whether it is capacitor or whether it is for resistor or whether it is for inductor, the law remains same. Nothing changes for this law. Actually, there are two laws that are there. Can anyone tell me what is the first law, law number 1? Hmm? No one knows it. Is that so? Huh? No one knows it. The first law is known as the junction law. You can also call it the charge law, or you can also call it the current law. What is this junction law or charge law or current law? Anyone? If there are different branches meeting at a junction, if there are different branches which are meeting at a junction, here as you can see the name of the junction is A. This law is based on, you can call it law of conservation of charge, or you can call it law of conservation of current. It's basically better to call it law of conservation of charge. This junction is not going to eat up any charge. This junction definitely is not going to eat up any charge. So now can anyone tell me what would this junction or charge law would be? this junction or this point A is not going to eat up. It's not hungry. So it's not going to eat up any charge. So what would be the charge law or the junction law? Yes, or the current law for that matter. If instead of charges Q1, Q2, Q3, Q4, Q5, I can draw current I1, I2, I3, I4, I5. Yes? Everyone is there in the class, no? Huh? Everyone is there in the
Yes, sir.
class?
Yes, sir.
Yes, yes. Tell me, sir. I'm waiting, sir. What will be this junction law or charge law or current law? It is based on law of conservation of charge. This should be good enough to tell you. Yes, tell me. Anyone sitting, chilling out? Tell me. What would be this charge law, junction law? Eh? Sir, we don't know. I know that you don't know, but I've told you everything that you have to know about it. No one knows it?
Summation of all charges is 0, sir.
So does it take 20 hours to say this? Summation of all charges is 0, or in just a simple case, I can say the incoming charge, if I take it as positive, then the outgoing charge becomes negative. So basically, I can say in more simpler terms, incoming charge will be equal to the outgoing charge. Yes or no? Huh? What are the incoming charges here? What are the incoming charges here? Q1 plus Q2 plus Q5 will be equal to Q3 plus Q4. Do we understand this?
Yes, sir.
Now, instead of charges, I could have called them currents. Flow of charge is nothing but rate of flow of charge is current. So instead of charges, I could have called them current. So it would have become I1 plus I2 plus I5 is equal to I3 plus I4. Do we understand this? That is
Yes, sir.
very simply law of conservation of charge, or you can call it junction law, or you can call it charge law, or you can call it current law. I'll give you 1 minute to note this down. Okay, the first one is known as the junction law, charge law, or current law. What is the second one known as?
Loop law.
The second one, chalo, we have woken up. The second one is known as loop law because it is applied in a loop, or you can call it the voltage law.
Voltage.
What does this state? What is this based on? That was based on law of conservation of charge. This? Huh? What is this based on? I don't know, sir. Well, let us first write this junction law. How is the junction law written? How is loop law written? It is always applied in a loop. How is loop law written? So it says that summation of all the potential drop across all the elements in a closed loop, if you move in a closed loop, is 0. So if you move in a closed loop, the summation of all the potential drop
Sir,
will
screen is paused, sir.
be taken as 0. You can write it on your own. I'm speaking. Nothing I've drawn, don't worry. Summation of all potential drop in a loop would be taken as 0. Now, what is this law based on? This is based on law of
Voltage. Voltage.
conservation of voltage. Law of conservation of energy. This is based on law of conservation of energy. If you move in a closed loop in an electric field or a gravitational field, the work done is zero. Do we remember this? Huh?
Yes, sir.
So if you move in a closed loop in a gravitational field, the change of potential energy is zero. Or you can write down that the work done by gravitational field is zero. Yes or no? Or you can write down the change in potential is zero. Yes or no?
Yes,
This
sir.
is your loop law. Or you can write it out like this. Integral of E dot dl is zero. Do we remember this integral of E dot dl? Or you can write it loud like this. Integral of F dot dl is zero. I know that you have forgotten this, because the only thing you have to forget is the habit of forgetting things, and that is the only thing that you don't forget. This is just a recap of all those things that we should have remembered, but we have failed to remember. How many of you remember this stuff that I've written? Anyone remember this stuff?
Yes, sir.
Eh? Seriously? That's a surprise. That's
Really,
a
sir.
that's a big surprise. If you remember it, that means you are doing good. Anyways, I will give you 2 minutes to note this down. Let me know once you are done. That was law of conservation of energy or loop law. Now, what we have written in this loop law is the sum of potential drop or sum of potential is zero. Now, how are you going to apply this? That is what you need to understand. How are you going to apply this? Now, how you're going to apply this? There are actually 4 elements in the circuit that are going to come. In this chapter, 1 element. In the next chapter, the next element. And in the chapter on EMI, the 3rd element. And the 4th element is battery, which will be coming in all these 4 chapters. So there are 4 things, and out of this we'll try to understand the 3. There are 3 things that you have to understand. There are 3 elements that you will have to understand that will be coming in this circuit or the loop that you are going to create. The first element is going to be what? Huh? The first element that is going to be coming is you will be coming as the battery element will be coming. Now this potential, you have to find out this change in potential. Now in the loop that you are going to create, you will get this elements and you will have to move across them. What do I mean by moving across them? For example, this is a battery and you will move across this battery, and let us say you will move across like this. When you move across like this across a battery, you are moving from the negative terminal to the positive terminal that you are going. That means you are going from a point of lower potential to a point of higher potential. Do we understand this?
Yes, sir.
You're going from a potential, lower potential to higher potential. That means your potential is increasing. In this, what you have to understand that if potential increases, the increase in potential is taken as positive. If the potential decreases, that is taken as negative. So when you are going across the battery in the pink direction, it will be taken as rise. Do we understand this?
Yes,
The
sir.
potential has risen, and if the battery EMF is E, you will write this as, you will write this potential as, you will write this potential as plus E. Oops. You will write this potential as plus E. Whereas if you are moving across the battery in the reverse direction, when I say reverse direction, that means you are moving like this. You are moving from the positive terminal to the negative terminal. You are moving from a point of higher potential to a point of lower potential. Your potential drops, and drop in potential is taken as negative. So this thing would be taken as minus E. Do we understand this, or this has gone above our head saying bye bye? Sab ho gaya, kafi hai, enough. Leave it. Understand this?
Understood, sir.
Don't start xeroxing. I'll give you time to xerox. First understand the other 2 elements, then xerox. That is the first element that will come. That will be battery. What is the second element that is going to come? Our new friend, capacitor. Now our new friend capacitor will come. Now capacitor also has a positive plate and a negative plate. So now you can apply some common sense, which all of you have in abundance. When will I take it as positive and when will I take it as negative? Yes, tell me. For example, this is the capacitor. And let us say this is the negative plate of the capacitor and this is the positive plate of the capacitor. When will the capacitance of this capacitor is C and the charge on this capacitor is Q? The capacitance of the capacitor is C and the charge on the capacitor is Q. When are you going to take the potential positive and when are you going to take the potential negative? Any idea? Everyone is chilling out. No idea. Yes.
Same as battery, sir.
Same as battery, sir. What do you mean by that, sir? So whenever I am moving across the capacitor from the negative terminal to the positive terminal, the potential change has to be taken as positive. Now, how much will be the potential change? For a battery, the potential change was plus or minus E. What will be the value for a capacitor? Remember, we have only studied two formula in a capacitor. Yes. What will be the change of potential? How much will you take it? No one knows it.
Q by C, sir.
Yes. Chalo. Someone is listening. Plus Q by C. So it will be taken as plus Q by C in this case. Now, if I take the same thing in the reverse sense, when I move from the positive terminal to the negative terminal like this, the same thing would be taken as minus Q by C. These are the only two formulas that we have studied in the entire chapter. What is the third element which we are going to do together with this? Yes.
Sister, sir.
Resistor.
Yes, our new friend, which is not till now our friend, but is going to be our friend. Register. Now, in case of a register, there will be no charge, but there will be current. So this is the dung 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 dung. This is the register. Resistance is R, and this is the current. Current is flowing like this. Then I move like this. Now remember, current that is coming in the next chapter very soon. Current is the flow of charges. Yes or no?
Yes,
Huh?
sir.
And whenever we talk about direction of current, I told you about direction of charge or direction of current, we always take the direction of flow of which charge? Positive or negative?
Negative, sir.
Huh?
Negative, sir.
Well done, sir. It's exactly opposite, sir. Whenever we talk about the direction of flow of charge or direction of flow of current, we're always talking about the direction of flow of positive charges. So the direction of current given here, even though current does not flow because of positive charges, current always flows because of electrons, which are negative charges. But the direction of current, we call it conventional direction of current. Direction of current is taken as the direction of flow of positive charges. So here, the pink direction is the direction of flow of current, which is also the direction of flow of positive charges. That is how it is assumed. Now, positive charges always flow from a point of which point? Which point?
Lower to higher, sir.
Current positive charges flow from lower to higher.
Little lower, sir.
Deep breath. Open your eyes. Look at the universe. Please look at the 4% that you see. Don't look at the 96% that you cannot see. And please remain in this universe. In this universe, positive charges always flow from where to where?
Little lower, sir.
Huh?
Higher to lower, sir.
Higher to lower, sir. So please remain in this universe, sir. Do not go into the anti-matter universe where positive charges start to flow from negative to positive. Yes, in a universe which is exactly opposite to us, antimatter universe, that will happen. This universe is good. So they flow from higher potential to lower potential. That means current also flows from higher potential to lower potential. So if I'm moving from higher to lower, if I'm moving from higher to lower, this will be taken as negative. And the only formula that you are going to study in the chapter of current is V is equal to IR. So it will be taken as minus I into R in the case of a resistance. If you are flowing in the direction of current, if you are moving opposite to the direction of current, do we understand what I am saying here, or it is going above our head saying bye bye sir, ho gaya sir, nikal jao.
Turning, sir.
So if you are moving opposite to the direction of current, the potential drop, which is I into R, will be taken as positive. Now you can start your Xerox machines and Xerox what is there on the board. I hope you have understood this. Once you have understood this, you don't need to look up and see what is written on the board. You should be able to write it on your own. If you are able to write it, that means you have understood this. If you are still looking up, that means you are still Xeroxing it and you need to try once again. So if you want to Xerox it, sit like this, understand everything. Take 2 minutes. This, understood. Then once your head goes down, you should only come up to say, yes, sir, I am done. Nothing else. But if you are doing dik, 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 so in the examination hall, you will also be doing dik, dik, this question gone, this question gone, this question gone. So your head movement will be like this. Got it? Understand it? Do it. I'll give you time. Because in the entire chapter that is going to come, this is the only thing that you have to understand. If you understand this, the entire chapter is done. If you don't understand this, there are lots of things I don't understand. I don't understand quantum physics, but my life still goes on. 2 minutes, 3 minutes, understand it, write it on your own, in your own language. So once you understand this, what we are going to do is I'm going to make a fictitious circuit, and then we are going to apply the law in this fictitious circuit and try to understand how do I apply this concept that we have studied in this junction, in this loop law. Now, since we are not going to deal with resistance now, so I will draw one circuit of pure resistance and I will draw one circuit of pure current side by side. Try to see what I have done and how I have done it. And I always do things in the same manner. So let me now start. I have this battery, one capacitor, one more battery. I mean, this is just a fictitious diagram, so I can put infinite number of batteries and I could put infinite number of capacitors. That does not make any difference to the eventual answer. The eventual circuit may be whatever it is. So I've just drawn a fictitious circuit. Now let me call the battery ka EMF as E1, this battery as E2, and this battery as E3. Let me call this capacitor as C1, this capacitor as C2, and this capacitor as C3. Now what I'm going to do is, since there is more than one battery, I cannot solve it by series parallel combination. You cannot solve it by series parallel combination. You will have to, and here I've assumed that all the capacitors are initially uncharged. So this is the simplest possible case that we are going to see. Now how I am going to apply this loop law? I don't know the charges on each capacitor, so and I have to apply loop law. So what do I do? This is how I do it. I take this leftmost down point and call it point A, and I start from point A, and I will move in the loop. And in which loop I will move? I will move in the loop in this fashion. I always move like this. I don't know why. I will move in the loop like this. Now I don't know which battery is powerful, which battery is strong, which battery is what. I don't know their values. Doesn't matter. You don't have to see which battery is positive, which plate is positive. You don't have to see. You just have to take assumptions on your own. So I assume that whatever charge comes. Remember, all the capacitors are initially uncharged. So I start and I assume that this capacitor gets plus Q charge. This plate gets plus Q charge. This is just my assumption. If my charge comes positive, my assumption was correct. If my charge comes negative, my assumption was wrong. Doesn't make any difference to the eventual answer. This plate gets plus Q. This plate will get minus Q. Then I come on the next plate. Now remember, all the capacitors are initially uncharged. So this plate will get plus Q. This plate will get minus Q. You will say, sir, this plate is connected to the negative terminal of the battery. No, no, no. I'm not looking at the positive and the negative terminal. I'm just starting to give plus Q, minus Q, and so on. So first plate that I will encounter, I will call it plus. And the second plate that I will encounter, I will call it the minus. Do we understand this, or this is gone above? Let's saying bye-bye. Understood this or gone?
Understood, sir.
In the dark matter, 96% of the universe gone there. I can't see it. Okay. Then again, I move. I see the battery. Again, I see a capacitor. I call this plate as positive and I call this plate as negative. The next question that you can ask, sir, why have you given similar charges? Because all the capacitors were initially uncharged and finally they will have the same charge. I know it. You should also know it. That's it. Now I just have to apply loop law. So what I'm going to do, I'm going to start from this point and I'm going to come back to this point. Change in potential has to be 0. Do we understand this?
Sir.
Change in potential is 0. So now I move. You can call the potential of this point as VA if you want to. There's a benefit in that. I will tell you that later on. So I start from point A. The potential of point A is VA. Now the first element that I'm going to encounter is this battery, and see how I'm moving in the loop. I'm moving anti-clockwise. So I will encounter this battery and I will go like this across the battery because I've written my direction of loop. So I will encounter this battery and I will encounter this battery and I will move from the negative terminal to the positive terminal. Yes or no?
Sir.
So now there is a potential change. How much is the potential change? When I move across this
Plus C,
battery?
sir.
Why plus? Because I'm going to higher potential. So I write it as VA plus E1. Everyone understands this?
Sir.
Then I move to this green capacitor. See, I cannot change my rotation, so I have to go anti-clockwise. So I move across this green capacitor and I move from where to where and what is the drop or rise. First, write this down, then do it on your own. You can draw your own fictitious circuit. Yes. What happens now? Rise
SQ
or
by
drop?
C.
Rise or drop? And how much is the rise or drop? Take a deep breath. Open your eyes. Look at what do you see and then tell me. Yes.
Minus Q by C.
Open your eyes. Open your eyes. Try again. Minus Q by C1. Open your eyes and see. You can't see the dark matter, but you can see what is on the board. Please open your eyes and see. This is a wonderful universe that we are living in. Next one. I come across this battery. Ding, 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 ding. And I have to move like this. Guess what happens now? Open your eyes and see what you can see.
Minus C2.
See? Now the universe is looking so beautiful. Minus E2. Take a deep breath. Open your eyes and see what do you see. And don't see what you don't see.
Minus Q by C2.
See? If you look at this universe, this is actually wonderful. That's why I love it. These things are so simple in this universe. Next one. I'm running short of colors.
Minus C3.
I've run short of colors, so I will use one of the colors which have been previously used. I'll use this one. Oh, yellow, 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 looking same fellow. Yes. I have to move like this.
minus q by c3.
Minus q by c3. Now I get to the same point, so I call it as VA. And you can see very simply this VA, we are going to get cancelled. So even if you don't write VA, it doesn't make any difference. I just wrote it because that's I wanted to be theoretically correct. Do we understand this? This is
Sir.
the equation. This is the equation. And as you can see, there's only one unknown here, and that unknown is q. You can solve for q and get the value of q. If the value of q turns out to be positive, that means your assumption were correct. The value of q turns out to be negative, that means your assumption was wrong. Do we understand this? Yes or no? This is gone above or saying bye bye, sir. Ho gaya.
Understood, sir.
Fine, sir. Done, sir. Okay. Don't start your Xerox machine. I will give you one more here on the right hand side. After that, you can start your Xerox machines. So I now change it. But remember, there is no change here. I'm just trying to replicate the circuit to the best of my abilities. And this is the best of my ability. I can call this as E1. I can call this as R1. I can call this as E2. I can call this as R2. I can call this as E3. And I can call this as R3. Now, if I had to apply the same law here, how will I apply it? A. Then I will gumo in the circuit. Dung, 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 dung. Like this. There I had assumed charge flowing Q. Here I will assume what? Current flowing I. Do we understand this? And doesn't matter what the direction I choose. I just choose one direction. If my answer, if my assumption is correct, it will come positive. If my assumption is wrong, it will come negative. Don't worry about that. Shall we begin this journey of writing the equation for this one? Huh?
Yes, sir.
Just give me one thing. I just decorate this stuff. Make it good, good, good. Yellow, 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 dirty fellow. So this yellow dirty fellow is for this one. And the next one that will come in green would be for this one because I don't have enough space there. So I will write it in blue, and the blue one starts with this. The blue one stands for the right one. Yes, how do I start?
Plus C1.
अरे VA कहाँ गया? VA. Yes?
Plus E1
Plus E1.
minus IR. IR1
See? Take a deep breath. Yes.
minus I2 E2
Open your eyes, beta. It is wonderful.
Minus E2, sir.
World is wonderful. Universe is beautiful. Yes.
minus IR2
Minus IR2.
minus
C3.
minus E3
Don't look at the
Minus
dark matter.
C3.
Don't look at the dark matter. Look at the matter that you see.
minus IR3 is equals to VA.
This is the equation, and I have not drawn anything there because I think you have understood the entire concept. This is the equation when applied to a register circuit. You can see they're exactly same. I could have taken the direction of current reverse. Doesn't matter what direction I take. Doesn't matter. Doesn't matter I have to move anti-clockwise. I can move clockwise also. But this is how I've done it always throughout my life. And I am a what you call a donkey. I start to do, if I understand things in one way, I will always do it in that way. A donkey does that, and I love donkeys. You know, it keeps on doing the same thing and it becomes good in that. You must have heard about that story of washerman and his donkey, Dhobi and his Gada. Had heard that story, Dhobi and Gada? So there's a washerman who goes to the ghat river bed to clean clothes. So he has a very beautiful donkey. So one day he puts all the clothes on a donkey and he walks in front of him, and the donkey follows him, and they go to the ghat. He cleans his stuff. He again puts the clean stuff on the donkey, and he walks him back. Second day, same thing. He puts the clothes on the donkey, walks in front of him, goes to the ghat. cleans the clothes, comes back, walks in front of the donkey. Third day also does the same thing. Fourth day, what he does? He just puts the clothes on the donkey's back, and donkey goes to the riverbed, and he's chilling out and coming aram se. I do the same thing, same way. If you want to be a donkey, you can do it this way. If you want to be smart, you can do it in another way. We have understood this, yes or no?
Yes, sir.
Now you can make your own fictitious circuit, draw that circuit, write the equation on that. I'll give you 2 minutes to do that. Okay, then we can move ahead in life then, sir. And how do we move ahead in life? I give you a question and you solve it and we move ahead in life. So this is how the question looks like. Will there be a question in there? Okay, I've not opened your favorite book today. So I will devise a question on my own. I'm not bad at it. And remember, the questions are only fictitious. And you must understand that there are infinite number of questions possible because I can make infinite circuits and we don't have infinite time. Let us say that the battery ka voltage is E, this one, this is C, this is 2E, this is 2C, and this is 3C. And the question is pretty damn simple. Find out the charges appearing on all the capacitors. Initially, all the capacitors are uncharged. I'll give you 2 minutes to show your talents. I'll assume that it is correct. So how do I go about it? That told you I keep on repeating this, doing the same thing like this. I will start from this point A. I will turn back. I will come back. Let me just assume some charges on it. How do I give charges? I assume that the current is flowing like this. So I assume that the current flows like this. So this plate will get plus Q charge. This plate will get minus Q charge. Current still flows in the same direction. Plus Q, minus Q, plus Q, and minus Q. Do we understand this? Yes or no?
Yes, sir.
I just write the equation, get the answer, and I will stay happily ever after. So my equation looks like this. Anyone can tell me the equation?
VA plus E minus Q by C,
Plus E minus
Q by C minus 2E minus Q by 2C minus Q by 3C equals to VA.
that's it. That looks correct. You can cancel this VA, and from here you should get the value of Q. How much is the value of Q coming?
11E by 6C
Plus or minus?
minus
That means my assumption was wrong. It is coming minus
11E by 6C.
That means my assumption was wrong, and the plate which I considered positive was not positive, it was in fact negative. Do we understand this, or this has gone above it saying bye bye?
Understood, sir.
Eh? Okay. Everyone
Minus
got this?
E6C by 11, sir.
Everyone got this, bacha?
Sir.
Remember, you may take any direction of charge, any plate as positive, any plate as negative, but remember your final answer should be same.
Sir, we
This
got a different answer, sir.
then you must have done something wrong, beta. Please check your answer. You can, I think you can calculate this. Yes or no?
First,
Sir,
Yes, beta.
we got minus 6EC by 11.
I don't know if you can't add and subtract from here. I can't help you. I can only
this
I can only tell you how the equation is made. If you can't solve it from here, I can't help you. You will have to help yourself.
sir,
Yes. Yes, beta. Tell me what.
Sir, minus 6EC by 11, sir.
minus 6e by 11. Okay, then this gentleman might have given me the wrong answer. I don't add and subtract. Pakka?
Yes, sir.
Yes, the answer that was given to me was ulta.
That is what we were saying, sir.
So I just believe that you would have added and subtracted. I don't add and subtract. I just write what you tell me. So that is the answer. Anyone got this?
C will be
It's
on
on the
numerator, sir.
numerator, sir.
C will be on the numerator, sir. See, so many mistakes were there with this question.
Yes, sir.
So we should not look into the dark matter. I was just looking, someone is going to tell me the correct answer or not. E by C does not have the dimension of cube high. I can't help you with calculations, I'm sorry. So you will have to live with that. I will just tell you the equation and after that I'm done. This comes this question, this is taken from your favorite book, but the question is wrong. So I'll just correct it. I will just correct it. And instead of making this as 12, I will make it as 24. So you have to find the charges on each of the capacitor. There are two capacitors as you can see. And they are also asking you to find out VA minus O. Chalo, first find out this. The charge on each capacitor. I'll give you 2 minutes to give me the answer. Okay, so how are you supposed to do this? Same thing. They have made one point as A, so I will also, just for the change, I will take that point as A, and then I will move in the loop from this point A and come back to the same point A. So now, can anyone tell me the equation? Huh?
A plus 12 minus q by 4
VA
is 12
plus 12
minus q by 4
minus Q by 4
minus 24 minus q by 2 is equal to VA.
If your answer comes positive, that means your assumption of the positive plate was correct. If your answer becomes negative, that means the positive plate was not positive, it was negative. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now in some of the questions, what can be asked and what was asked in this question? In some of the question, now why I called one point as A. In some of the question, let us go back to this question. They might sometimes ask you, they might make 2 points here. One is point A and one is point B. And then they might ask you what is the potential difference between the 2 points, VA minus VB. That is why I call one point as A, because sometimes they ask questions like this. What is VA minus VB? Now, since I have told you everything that you needed to know in this universe about this, I will give you 2 minutes to tell me, going back to the previous question, can you tell me the value of VA minus VB? And whatever you need to know to find out VA minus VB, I have already told you. So I'll give you 2 minutes for brainstorming session. There has to be some brainstorming, because if you just copy what is there on the board, it is not going to help you. So I'll leave 2 minutes for your brainstorming session. Can you tell me what and how we will find out VA minus VB? Your time starts now. How am I supposed to do that? I've already found out the value of Q. Now, what do I do? I can first, since I've got the value of Q, I can first write the value of Q. So this plate becomes minus 6 EC by 11, and this plate becomes plus 6 EC by 11. Do we understand this?
Yes, sir.
Sir.
The only thing I have to do now is to apply the loop law, but not the loop law. I will start from point A and end my journey on point B. How do I do it? And that is why I started with point A and I call the potential as VA. VA, can anyone tell me what is the next thing? I told you that story of the washerman and the donkey. You just have to do the same thing.
So, plus
No,
E
VA plus E
minus QC minus Q by C.
I'm moving like this. I'm moving like this across this capacitor.
Plus Q by C.
How much is Q?
Minus 6 EC by 11.
Don't get confused. When I say charge on the capacitor, is always charge on the positive plate, not the charge on the negative plate. So you are getting confused here. I am moving from the negative plate to the positive plate. Potential should rise. How much it should rise? The charge is 6 EC by 11 divided by C. That must be equal to I end my journey on B. So now I will get the value of VA minus VB. VA minus VB will be equal to how much? Minus 17. You can cancel this. Minus 17 by minus 17 minus 17 by 11 times E. Do we understand how I have done this? Do we understand how this is done? Yes or no?
Yes, sir.
I have not done anything different. Once I get the value of Q, I just move from A to B and I stop my journey at point B. And that's it. I get the value of VA minus VB. You understand this?
Yes, sir.
Everyone has noted this down.
Yes, sir.
Then I will give you one question. And I hope that all of you get that question correctly. Can I expect that or not?
Yes, sir.
Pakka na, sir?
Pakka, sir.
Okay. Let us see if you can give me the answer. Okay, I don't have any written questions, so I'll have to devise my own. So I'll devise this question. There are two things that has been asked in this question. And the two things are, what are the charges coming on each capacitor, both the capacitors, and what is the potential difference between the points A and B, and I will need answer to both of these questions. What is the charge coming on each capacitor, and what is VA minus VB? I'll give you 2 minutes. Take a deep breath and give me the answer for this question. You have time, don't worry about it. Okay, let me do it. And again, I'll do the same thing. I will
Sir,
move.
6, sir.
I will move in the loop like this. I
Sir,
will-
Q is equal to 4. V minus V is equal to 6.
Okay, I'm getting the answers. Let me just do my thing. Plus Q minus Q. Who will help me in making the equation? First of all, I have to find out the value of Q. Yes. What is the equation for that? Anyone?
VA minus 2V
VA.
minus 2V
I just write 2 volt is okay. V was volt SI unit. Okay. VA minus 2.
minus Q by 3
Remember this charge will come in microcoulomb because this is in micro. Okay. Minus Q by 3
plus 4
plus 4
minus Q by 6.
minus Q by 6. I again end up with VA. Yes, this is correct. This should give me the value of Q in microcoulombs. Remember, what is the value of Q coming?
4, sir.
Huh?
4
4 plus or minus?
plus.
It is important because if you make a mistake, the value of VA minus VB will be wrong. Plus 4, everyone got this? Why I'm
Yes,
writing
sir.
that? Well done. So this is coming as plus 4. That means my assumption was wrong. My assumption was right. Let me now write plus 4 here. And this becomes minus 4. Remember, it is written in microcoulombs. Now again, I have to go from A to C. I start my journey. What is the next thing that I write? I have to find VA minus VB also. Yes. No one is going to help me out.
VA minus 2 minus 4 is equal to VB.
VA minus 2. And then I go across this battery and I am going like this across the battery. So I move from positive terminal to the negative terminal. So it should be minus how much?
4 by 3, sir.
4 by 3, sir. And I can
equal
now
to-
finish my journey at point B because I don't have to go any further. So that will be the value of VA minus VB. How much VA minus VB is coming?
10 by 3, sir.
Plus 10 by 3. And that should be the answer if you have done the calculations correctly. I leave that part. Do we understand this, everyone?
Yes, sir.
Yes, sir.
Okay. Well done. Comes the next question. Everyone understands this, what we are doing? Huh?
Sir.
Hmm. So here comes this question. And you can imagine that we have not done this topic, but we can still solve this question. Two things I have to find out. Two things you have to find out. You have to tell me what is the current in the circuit. What is the current in the circuit and what is VA minus VB. Do you understand this question? Huh?
Yes, sir.
Current in the circuit and the potential drop between A and B. I'll give you 2 minutes to do this. So this is the case where capacitors have got initial charge Remember, the capacitor have got initial charge. C capacitor has got a charge, has been charged to a potential V, and 2C capacitor has been charged to a potential of 2V. You have to find out the final charge on the capacitor when the switch is closed. I'll give you 2 minutes to do it. Well, let me do this for you, and I hope you will get enough material to do it before. Now, initially, this plate has plus CV charge, and this plate has minus CV charge. This plate has plus 4 CV charge, and this plate has minus 4 CV charge. Do we understand this? The blue thing are the initial charges. Now I can draw it in a different diagram, but let me try to do it in the same diagram if you can. Okay, I don't know what has happened. So again, I only know one thing. I will start from this point and I will go like this and something I'll do. Okay. Now going on the same thing, let me call, and now I'm calling it by the green thing. Let me take this plus and minus off because I've already written their charges in positive and negative thing. Let me take this plus and minus off. Okay. So do we understand this? This is the initial configuration that that was given to me, that is known to me. Now I don't know what has happened, which case is positive, negative, but again I'll go on my assumption. Let me call this plate as positive plate plus Q. Then the other plate becomes minus plate. That is how I started the entire question previously, right? Now once I come to the second capacitor, now what was happening in the previous case, since all the capacitors were initially uncharged, I could call the next plate as plus Q. But here I cannot call the next plate as plus Q because the capacitor were initially charged. So I will have to find out the charge of the next plate. Now how I am going to find out the charge of the next plate? Remember, these two plates of these two capacitors, they form an isolated system. They form an isolated system. That means whatever charge flows, it will flow from this plate, the upper plate, to the lower plate, or lower plate to the other plate. The total charge of the system should remain constant. Do we understand this? When I say system, the system is the system that I've created, the red one. Do we understand this? The total charge of this system should remain constant. Do we understand this?
Sir.
Do we understand this?
Yes, sir.
Now again, I am going to call this plate as the positive plate and this plate as the negative plate, no matter what. Now, what will be the charge coming on this plate? I'm calling it positive charge. Now, if I look before connection is the blue one. This plate has minus CV charge, and this plate has plus 4 CV charge. So the total charge on these two plates together was plus 3 CV. Yes or no?
Yes, sir.
Now, after connection, the total charge also should remain plus 3 CV. But minus Q has already gone on the upper plate. So whatever remains will come on the lower plate. What remains? So what remains is 3 CV plus Q. So when I add up these two charges, the green charges, I must get plus 3 CV. Do we understand this?
Sir.
Okay. So upper plate and lower plate adding up should become 3 CV. I've already given minus Q on that plate. So whatever remains comes on the lower plate. Do we understand this? So this plate is a positive plate. So the other plate, and I don't have any space written here, so I will just write it here. The other plate, the charge on this plate will become minus of 3 CV plus Q. Do we understand this? This is simple math, plus and minus I have done. Okay. Do we get this?
Yes, sir.
Now, just to check whether my charge distribution is correct or not, I can take these two plates also as one isolated system. I'm just checking whether my distribution is correct or not. Now, if I look at the left hand side, before connection, the total charge on the plate, this plate was having plus CV, this plate was having minus 4 CV. Before connection, the charge was minus 3 CV. And if I look at my final charges, this one has plus Q and this one has minus of this one. If I add these two charges, I will also get minus 3 CV. That means my charge distribution is good. Do we understand this?
Yes, sir.
So basically what I have done in just 5 minutes is nothing but added, subtracted and find out the charges. There is nothing big I have done here. Do we understand this? Do we understand
Yes,
this?
sir. Yes, sir.
Now I know the charges. Now I do what I have been doing. VA is the potential of this point. Now again, I move the capacitor. Remember, the green are the charges on the capacitor. And I have taken this plate as positive. So VA minus Q by C. Do we understand this?
Yes, sir.
Then again, I have taken the next plate also positive. So minus, what is the charge? 3 CV plus Q divided by 2C, because the capacitance is 2C, will be again equal to VA. I can cancel this VA, and from here I will get the value of Q. Depending on the value of Q, all the charges will come on their own. Do we understand this, or this has gone above our head saying bye bye sir, ho gaya sir, enough? This has gone into the dark matter. 96%. Do we understand this? What is the value of Q you are getting from here? Can anyone tell me? Ma? I don't know, sir. What is the value of Q you are getting?
Minus 3 C square V by C minus 2.
I will not solve it. I hope you can get the answer. I'll give you 2 minutes to get the answer. What is the
Minus
answer that
C.
we are getting?
Minus CV.
That looks like an answer from this universe and in the 4% that we see, not the 96% that we don't see. That means my assumption of the first plate of the capacitor was wrong. It does not remain a positive plate. It becomes a negative plate. Do we understand this, or bye bye?
Understood, sir.
How many people bye bye?
Everybody understood, sir.
Even after writing that equation, if you give the answer in terms of C square V minus 1, what do I do? Anyways, I always think that students are like cash vouchers. Sometimes the cash voucher may not work, but many a times it will work if you put the right codes. Shall we move on to the next question? Huh?
Sir.
Yes, sir.
Let's see. Right codes. I have this capacitor. Let me make the space thoda zyada so that I'll get more time, more space. This capacitor, this capacitor is C, charged to a voltage of V. This capacitor is 2C charged to a voltage of 3V. This is switch. This plate is positive and this plate is negative. This plate is positive and this plate is negative. You have to know which plate is positive and negative, otherwise you will not be able to solve it. Yes. You have to find out the what? The charge is coming on both the capacitors after the connection has been made. I'll give you 2 minutes to show your talents. Else I'll show mine. So how do I proceed? I don't know much about it, so I start from this point A and I do my thing. But first of all, let us write what was the charge here initially. This plate has plus CV, this plate has minus CV initially. This plate has plus 6 CV and this plate has minus 6 CV. Do we understand this? Yes or no? So I now then just
Sir.
take this out so that I get some space to work around. I don't know what are the charges. Let me call this charge as plus Q and let me call this charge as minus Q. Then I must take the isolated system. And this is the isolated system. The total charge on this system is how much? Huh? Plus 5 CV. Let me call this plate as a positive plate. How much charge will come on this plate?
CV minus Q plus Q.
How much CV minus Q?
5 CV plus Q.
5 CV plus Q. That is exactly correct. And the charge on this plate will be minus of 5 CV plus Q. And you can check it from the other plates whether the charge is coming same. I think it will be coming same because I think that it is correct. Do we understand this? Yes or no?
Sir.
Yes.
And the only thing that is left is moving in a circle. I mean moving in a loop. VA minus Q by C minus 5 CV plus Q by 2C should be equal to VA. This should give me the value of Q. How much is the value of Q that you are getting?
It's 5 by 3 CV.
Plus or minus?
Minus.
Yes.
Minus 5 by 3 CV. So that has to be your answer. Do we get this, or this has gone above our head saying bye bye sir, bye bye, I'm going sir, enough sir, bye bye sir, bye bye sir.
Understood, sir.
Okay. Here is a question from your favorite book. And it comes with a bang. Now remember, once we solve this part of the question, there could be other parts as well, as evident from this question. A capacitor of capacitance 2 microfarad is charged to a potential difference of 12 volt. It is then connected to a uncharged capacitor. Remember, the second capacitor is uncharged, so it doesn't matter which plate is connected to which plate because the second capacitor is uncharged. Do we understand this? If the second capacitor was also charged, then they would have given you which plate is connected to which plate. We understand this, or bye-bye?
Understood, sir.
It is then connected to an uncharged capacitor of capacitance 4 microfarad as shown in the figure. Figure is there. Find the charge on each of the capacitor after the connection. The electrostatic potential energy stored in each of the two capacitors and the heat produced during the charge transfer. What was that energy equation of capacitor? Anyone remembers it?
Shell plus work done by battery plus work done external is equal to U final plus delta H.
It's your time to shine. Yesterday, Messi shown rose to the equation. One penalty, one field goal in the match, one more penalty in the penalty shootout. Now it's your time to become your Messi. 2 minutes you have to shine. 2 minutes. Messi did not get in the entire match 2 minutes of football time. Can you do it? So how are you supposed to do this? The 2 microfarad capacitor is charged to a potential difference of 12 volt. So let me assume that this is the positive plate and this is the negative plate. So this plate will get 24 microcoulomb. This plate will get minus 24 microcoulomb. Let me write it here on this side. Plus 24 minus 24 microcoulombs. Before connecting, this was having 0 and 0. I don't know. I call this charge as Q. And as always, I will call this plate as the positive plate and this plate as the negative plate. This plate has the positive plate. This plate has a charge plus Q. This plate has a charge minus Q. Then I look for my isolated system. Ding, 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 ding. Ding, 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 ding. Okay. What is the charge on the other plate? Anyone? I will call that as positive plate. How much is the charge on the other plate? Huh?
4 plus Q, sir.
24 plus Q, sir. And what is the charge on the other plate? Minus of 24 plus Q. The only thing I know is to gumo in this loop. So I gumoed in the loop. Now why I'm calling this point as Q? I should have called it as A. Okay, what is the equation that I get? Huh? No equation, sir. I don't know the equation, sir. I am new in the town, sir. How do I get the equation, sir? Yes? Huh?
Minus Q
VA minus
minus of 24 plus Q is equal to VA.
okay, I missed it. VA minus Q by 2 minus of 24 plus Q divided by 4 is equal to VA. This should give me the value of Q. How much is the value of Q that you are getting from here? I don't know, sir. It is such a difficult problem, sir. How do I know the answer?
8, sir.
8, sir? Plus 8 or sir or minus 8, sir?
Minus 8, sir.
Minus 8, sir. That means my assumption was not wrong. The positive plate of the capacitor remains positive and the negative plate remains negative. Anyways, doesn't matter. Did we get this answer? Yes or no?
Yes, sir.
So the charge on this first capacitor is minus 8. Now you can find the charge. I cannot call minus. So charge on the first capacitor is 8 microcoulomb. What is the charge on the next capacitor, on the second capacitor? Second capacitor.
16,
Second
sir.
capacitor. Huh?
16.
So let me just write it as 8 microcoulomb because when I call charge, I call the charge on the positive plate. So Q1, let me call this as capacitor number 1. Let me call this as capacitor number 2. So charge on capacitor 2 will be 16 microcoulomb. One part done. Do we understand this? Yes or no? Huh?
Yes, sir.
Ah. And what next? I can find out the energy stored in capacitor 1. What is the initial energy? Blue is the initial energy. Huh? Blue is the initial energy. What is the initial energy? No one knows it. What is the initial energy stored?
16, sir.
Huh?
16, sir.
16.
Sir.
Initial energy, bhai sahab, initial energy. Beta, initial energy. Initial, when nothing was there. Big Bang. At the time of Big Bang, what was the energy here? Initial energy, initial.
24.
24, sir.
Only two formulas we have done in the entire chapter. One is Q is CV, one is energy is half CV square.
144.
God. 144 microjoules. You just can't remember these formulas. I will pray to God that somehow something happens out of miracle. In the examination, all of a sudden Saraswati will come in front of you. She will say, oh, boom, 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 and then somehow you will clear. So that's the only way you can clear JEE. There's no other way out to clear JEE. You get me so disappointed. Anyways, I'll have to leave my disappointment for some other day. What is the final energy? U1 final. What is the final energy in that first capacitor? This is the first capacitor. What is the energy now in this capacitor?
88, sir.
Huh?
288.
I need to take a deep breath.
16, sir.
Open my eyes and look at the 4% of the universe that I can see. Yes, what is the answer for the final energy of the first capacitor?
16, sir.
Thank God, sir. God exists, sir. I had lost all the faith in God. Q square by 2C. Q square is 64 divided by 2C. I will not write the formula because there's no point of writing the formula. 16 not 16. 64 microjoules. I don't know what are you doing in the home. Okay, everything is okay. What is the final energy stored in the second capacitor? No, this is not 64, this is 16. My head has started spinning. Looking at your Krantikari answers, my head has started spinning. Okay, what is the final energy stored in the second capacitor?
32, sir.
Chalo, 32 microjoules. So that is the answer for part B, the final energy, the green ones. One more thing is remaining in this question, and that is to find out the heat produced. Can anyone tell me how much is the heat produced? I can't expect you to get me that answer. So I'll do it to get the, because if you can't find out the energy, you cannot find out the heat. There's no way you can find it out. So let me help you out with that answer and don't burden myself and yourselves. How will I find out the heat produced? So I will put this formula: initial energy plus work done by battery plus work done by external forces must be equal to final energy plus heat given. The initial energy is 144 microjoules. That is the initial energy. There is no work done by the battery. There is no external forces because there is no battery here, nothing here. That must be equal to U final. How much is U final? 16 plus 32 plus heat. 16 plus 32 is 48. I think whatever remains, I think 96 microjoules, if I am correct, is the heat given in this process. I will give you 2 minutes Take a deep breath. Write the solution and get me the answer. I'll give you 2 minutes. And I'm hoping for this one to be the one which brings smiles to everyone's faces. I can see some smiling faces, but that may be because of other heroics. I need smiling faces because of the answer. Getting the right answer. So this is the question. Again, it is taken from your favorite book, question number 47, whatever page it is, 168 or 169. Let's see if anyone can go somewhere near this question and get the answer. Again, it has different parts. Find the energy stored in each capacitor. So there are two capacitors which are charged. Remember, now they are charged. Both the capacitors are charged. And therefore, it is given. Find the energy stored in each capacitor. That is the first question. The positive plate of the first capacitor is now connected to the negative plate of the second. Oh, so that's why now plates are given. Find the new charges on the capacitor. Find the loss of electrostatic energy. Where does this energy go? You have 2 minutes, 4 minutes, 5 minutes. Please get somewhere near an answer. And I hope you try your best. I'll give you time. Try it. So how are we supposed to do this? Let me draw the diagram first. There is no diagram given in this question. Doesn't make any difference. I can draw the diagram on my own. So this is the diagram that I have drawn. Let us see. This capacitor is 5 microfarad and it is charged to 24 volt. This capacitor is 6 microfarad. It is charged to 12 volts. The positive plate of the first capacitor is connected to the negative plate. So let me call this plate as positive, this as negative. So this becomes negative and this becomes positive. Let us first write the charge. This charge on this plate will be 5 into 24. How much is 5 into 24? So this will be, yes, how much?
120.
This would be plus of 120 and this would be minus of 120. The other side is a negative plate. So this will be minus of how much?
2.
Minus of 72. This would be plus of 72. So far, so good. I take my point A. I don't know what is happening. So I call this plate as plus Q and this plate as minus Q. Now I have to find out the charge on this plate. So I just take my isolated system. Before connection, what was the charge on this isolated system? Plus 120 minus 72. How much is that? 48? Yes or no?
Yes, sir.
Let me call this plate as a positive plate. So what is the charge on this positive plate coming? 48 plus Q. Yes or no?
Yes, sir.
Yes, sir.
On this plate, it will be minus of 48 plus Q. I only know to do one thing once, so I will go more like this. Can anyone tell me what is the equation I am going to get? Can anyone tell me what is the equation I am going to get? No one? Okay, so the equation will be VA minus Q by 5
Minus
minus
48 plus Q by 6
48 plus Q by 6
is equal
is equal to VA. That
VA.
is correct.
Q is equal
Q, how much is coming? Q?
48.
40?
8, sir.
48? Same as
Yes, sir.
48. Plus 48 or minus 48?
Plus 48, sir.
Okay, that means our assumption was correct. Q is plus 48. So these are the charges coming on both of the plates. Did you check the answer? Is the answer coming same?
Yes, yes, sir.
Sir, we are getting minus 240 by 11.
I don't know. Have you made the same equation better as the equation here?
Yes, sir.
No. Then these people would have done some something. Answer is coming as 12. Uh, which question was there? I think they have solved it wrongly. You never know. I don't trust people, especially boys. 47. The answer that is given here is 21.8. So this definitely is not the answer. So if you can't calculate it from here, what do I do, beta? I have nothing to say that if you can't calculate it from here. How much you are getting, beta?
Minus 240 by 11.
Yes, that is what you will get. Minus 240 by 11. I don't know how you are calculating, bacha. May God help you in calculations. Okay. This is, let us say, number 1. This is, let us say, number 2. Let us talk about the initial energies. Let us talk about the initial energies of 1 and 2. What is the initial energy of 1?
140.
So I can find it out as half into C is 5 into V square is 24 square. How much is that coming?
1440, sir.
144
440.
microjoules, है ना?
Ah,
Okay, what is the initial energy of the second one? Half into 6 into 12 square. How much is that?
432, sir.
432 microjoules. How it can be? How this energy can be more than that?
One four.
Just don't know how to calculate, yaar. Come on. Just don't know how to calculate.
Sir, 111.
Acha, I'm asking about the initial energies, bhai. Yes, what are the initial energies? 1,
14.
1, 4.
What?
Take a deep breath. You can find out the initial and final energy. Let's not waste time on this. You can find out the final energies. What are the final energies? You can find it out by Q square by 2C. You can do that, yes or no? Once you get the initial and the final energies, you can apply the equation of capacitor U initial plus work done by the battery plus work done by the external agent shall be equal to U final plus heat developed. From here, you should get the value of heat developed. The answer that I see is 1770 microjoules. Anyways, I think you should be able to calculate the energies by taking a deep breath and finding out the answer, because the charge is not coming very good. It is coming as minus 240, and you might have problems in calculating this. But remember, if this question comes in your JEE, the numerical values will not be so difficult to calculate. Have you understood the concept of this question? Yes or no?
Sir,
That is the only thing. Once you get the value of this charge, beta, after that, it simply is simple maths. You have to find out the initial energy, final energy, and you must remember this equation. From this equation, you should be able to find out the heat. So with this, we come to an end of this type of questions that we were doing. In this, we only had one loop, and we were doing problems in that loop. But you can have problems where you don't have one loop and you have more than one loop. So in the next class, that is tomorrow, we will tackle those problems when we have not one but more than one loop. So I'll see you in the next class. Take care and God bless all of you. Did everyone of you understand what we have done in today's class?
sir.
What I would request is, please go back and solve all these questions once more, see the solution once more. If you have any doubt, please ask. Remember, we don't have time that we can come back and revise this topic again. So please remember that. Take care. And God bless all of you. I always pray that. Bye bye, everyone.
Bye, sir.
Bye, beta.